Hello guys, I am Nidhishri S. Pagalwadi, your science teacher, Sankalp Learning Solutions. In previous classes, we learned regarding the potential difference and also we solved regarding certain problems related to potential difference and we discussed regarding a device which is used to measure the potential difference, that is nothing but the voltmeter. In today's class, we are going to sum up the things which we learnt in the previous sessions. For example, in the first session, we discussed regarding the electric current, that is I. Okay, we discussed regarding the electric current, which is denoted by higher case I, that is capital letter I. Then in the upcoming session, in last sessions, that is in second and third sessions, we discussed regarding the potential difference. We discussed regarding potential difference. In today's sessions, we are going to see the relationship between the electric current and the potential difference. Means the Ohm's law, what is there, it states or it gives the relation. It gives the relationship between electric current and the potential difference. So when I say relationship, don't think that whether current is single, whether potential difference is married, or whether current is in a complicated relationship. No, not this. The relationship in physics will be different. Okay, so let us study this relationship between the current and the potential difference by considering some examples, some simple examples. So when we consider the examples, so it will be very easy for us to study this Ohm's law. So let us consider a case 1. Let us consider two cases. In case 1, let us consider the two beakers which are kept at a certain distance. Means the height differences will be there. It is not much. The height difference is there, but it is not much. So here I will take some water. Okay, let us take 50 ml of water in beaker A. In beaker B also I am taking 50 ml of water. Okay. See here, in both the beakers I took same quantity of water or same amount of water. Then let us connect these two beakers by a pipe. Okay. So what happens here? You can see the movement of water from beaker A to from beaker B. You can see the movement of water from A to B. Why the movement of water is from A to B? Even though the amount of water is same in both the beaker, there will be a flow from A to B. Why? Because we have here the height difference. What is the difference? Due to the difference in height, the flow of water is happening from, the flow of water is started from beaker A to beaker B. Here we have height difference. Okay. Now, we will consider case 2. We will consider case 2. Now, let us consider the two beakers. Okay, here also we will consider two beakers. This is C and this is D. Beaker name C, beaker is C, D. Then let us take 100 ml of water in the first beaker, that is in C, and let us take 25 ml of water in beaker D. And the height difference between the two beakers is quite more than the height difference in case A. Okay, let us take the difference in height quite more here. Now let us connect these two beakers. Let us connect these two beakers with a pipe. Okay. Let us connect these two beakers through a pipe. Now, when you see the flow of water here, the flow of water will be from C to D. The flow of water will be from C to D. And when you see the speed of flow of water, it is more. The water moves very speed at a very fast rate in case 2 than compared to case 1. In case 2 than compared to case 1. So here I can write flow of water. The first one is height difference is more here. height difference is more. Next we can write flow of water is more. Here flow of water is less than compared to case 2. Than compared to case 2. In case 1 the flow of water is less. Now this is regarding certain example. Let us consider a simple circuit with a bulb over here which is connected to a shell. Okay, then here switch is on, then this is a negative terminal, this is a positive terminal, this is a bulb and this is a switch. And the flow of current will be from positive terminal to negative terminal. With this we discussed in the previous sessions. Even though the flow of electrons will be from negative terminal to positive terminal, the flow of current will be from positive to negative. This is we will take as conventionally. We are taking it as conventionally. And the potential difference will be at the cell that is denoted by V. This is a potential difference V, current I, then this is a switch. Okay, now let us consider the height difference. Let us consider, or let us mingle, or let us try to bring these two concepts as a one concept. So what I am doing, I am taking height difference as potential difference. I am taking height difference as potential difference V. Now the flow of current, flow of water I am taking as I, that is current. So here it is flow of current or current flow. Okay, now in this situation what is happening, if the height is increased, flow of water will also increases. So here what is happening in the daily example, if height is increased, what is increasing there? Flow of water also increases. Flow of water is increasing or increases. Now height is related to what? We took height as potential difference. So if potential difference increases, flow of water is related to the flow of current. Current also increases. Okay, got to know how I related both the concepts. So here if the height increases, flow of water increases. Like that, if potential difference increases, what is the potential difference? That force, that energy, if that force to pull the electron increases, the flow also increases. If the flow of electron increases, obviously the current increases. We know the potential difference. What is that? Electric charge difference. So how that electric charge difference occurs? Due to the force or energy inside the battery. So that energy or a force, when it increases suddenly, the push for the electron also increases. When this push for the electrons increases, it directly increases the flow of a current. So here we can say the potential difference is directly proportional to the flow of current. The potential difference is directly proportional. This is a proportional sign. So what is this directly proportional? The directly proportional means what? If the potential difference increases, flow of current increases. If potential difference decreases, flow of current decreases. So by this we can say that potential difference always is directly proportional to the flow of current unless temperature remains constant. So here we have one big thread here. So here when the temperature remains constant, that time only they will be directly proportional. When the temperature is not constant, then the current changes. So we can't, this law is not applicable. This statement will not be right at that time. So for that, temperature should remain constant. So by this all we can state the Ohm's law as. So let me rub this analogy. So Ohm's law states that the potential difference across metal wire is directly proportional to the flow of current until what? Unless or until temperature remains constant. Okay, this is the Ohm's law. Okay, now according to Ohm's law, what happens? V is directly proportional to I. So when we have to remove this proportionality sign, we should replace it by V is equal to R into I. So we should replace. So here what happens? V is directly proportional to the flow of current and V is equal to R into I. So what is R here? Proportionality constant. It is termed as proportionality constant. Why we took? To remove the proportionality sign, we will consider R. Okay, proportionality constant. So here it is also known as a resistance. It is called as resistance. So what is this resistance is? As you see, the chemical reaction inside the battery releases some external force or energy which makes the electrons to displace from their actual position. So that movement of electrons results in the production of electric current. This we know. As we say in a statement, as we mark in a circuit the flow of current, it is not so easy for a flow of current in a circuit. It is not so smooth. Many obstructions or many disturbance will be there inside the circuit for the flow of current. So that disturbance, that obstruction inside the circuit for the flow of current is called as resistance. So what is resistance? It is the obstruction or disturbance against the flow of current. Disturbance against the flow of current. Okay, so this is resistance. V is equal to R into I. So when we consider V is equal to R into I, that is resistance, and I. Okay, so we here by the statements, that is resistance and the current statement, we can tell that R is inversely proportional to I. R is inversely proportional. How? If you solve for R is equal to V by I. When we will consider as certain constant, we can say that R is directly proportional. R is inversely proportional to the current. Inversely means we have to write 1 by reciprocal. What is inversely? If resistance increases, current decreases. That is, if disturbance increases in the circuit, if obstruction increases in the circuit, no doubt the flow of current decreases. If obstruction or disturbance inside the circuit is less, the flow of current will be smooth. So by this we can say the resistance will be inversely proportional to the flow of current. In the upcoming sessions, we will deal or we will learn more about the resistance. Until that, keep practicing. Have a nice day.